Take a look at these equations. They all represent the same mathematical idea, but written in completely different handwriting styles. But how can we make a machine understand them? That's what we will solve in this self-guided project. Imagine you are writing on your tablet. Each movement of your pen forms a stroke. And under the hood, it's nothing more than a collection of X and Y coordinates. As your pen moves, the system continuously records its position, capturing snapshots of where the tip is at each moment, resulting in a sequence of XY coordinates that together represent that stroke. The same idea applies even to something like the letter X, which is made of two separate strokes. We end up with a list of strokes, each one a sequence of X and Y coordinates, together forming the letter. Now, what we need is a function, something that can take this list of strokes and turn it into a format the machine can actually understand, while still handling the fact that different equations can have very different input lengths. At first, you might think a convolutional neural network is the right tool for this. And for something simple like recognizing a single digit, that works beautifully. But here the challenge is different. Is this an X or is it a 2? And even if you recognize both symbols correctly, how do you tell that the 2 is not just next to the X, but actually written as its exponent? In this case, there is a more elegant solution that naturally accounts for temporal dependencies. Instead of relying on a CNN, we turn to a recurrent neural network, a family of models designed to handle sequences, which makes them a far better match for the sequential nature of handwriting. So how exactly does the machine come to understand an equation like this? Or more precisely, what form does that understanding take? What does it actually output? Let's take a look at a latex version of the equation, broken down into its components. You can see individual symbols along with the relationships between them. It may look more digital, more structured, but it still captures the exact same idea. To simplify things even further, instead of thinking in terms of grouped structures, we break everything down into plain symbols and their relations. And when read from left to right, these pieces allow us to reconstruct the original formula. For a quick recap, our goal is to start with a list of strokes, feed that sequence into an RNN, and have it produce a sequence of symbols and relations. And that's it, right? Well, not quite, but we're getting there. To train a CNN, we typically feed an image into the model, get a prediction, compare that prediction with the ground truth, compute a loss, and then use that loss to propagate gradients backward through the network. Now, we can take that same principle and apply it to our RNN model, just with a different kind of loss, and features that reflect the sequential nature of the data. For feature representation, imagine writing the letter X at different positions on your tablet. Even though the location changes, it still represents the same X. But to the model, the raw input looks completely different. So the question becomes, how can we represent these variations in the same way? Or in other words, how do we extract the underlying features that make an X an X? As a human, how do you actually write the letter X? The answer isn't just in the final shape, it's in the motion of your hand. That motion can be captured as the difference between one point and the next. And when you map all of those movements into a coordinate system, the pattern that emerges looks something like a flower. To make this representation more robust, so it works across different handwriting styles, you can normalize the movement using something like the Euclidean distance between consecutive points. And this should help the model distinguish between a symbol like X and a symbol like pi. At that point, all that remains is to train the final model so it can predict the sequence of symbols and relations. And that's it for the introduction of this self-guided project about handwriting recognition.